Assalamualaikum warahmatullahi wabarakatuh and hello everyone. Today, our group will present for subject PHY260 and our main topic is system radar. And before we start, I will introduce our group members. Firstly, we have DANISH QASHRI bin Norazam, and secondly, we have Muhammad Irsyad Razin bin Rizwan, and next, we have Muhammad ARIF DANISH bin Zaidi, and next we have Muhammad AIMAN SANI bin Ordeta, and lastly is me, Muhammad Inas NURHAN bin Ibrahim. Now, I will explain about what is radar. Radar stands for radio detection and ranging. It is a technology that uses radio wave to detect and locate objects. Radar works by sending radio wave and receiving the reflex signals from an object. From these signals, radar can determine the object's distance, direction, and sometimes its speed. Because it can work in darkness and bad weather, radar is widely used in aviation, navigation, weather forecasting, and military system. Now, I will explain why radar is so important. Radar is a crucial technology because it essentially gives us eyes when we can see, easily cutting through dense fog, heavy rain, and total darkness to track objects. It doesn't just spot things, it provides precise, real-time data on their exact location, distance, direction, and speed, so operators can make smart, split-second decisions. This makes it an absolute cornerstone for safety, helping airplanes, ships, and cars navigate safely and avoid collisions every single day. On top of that, it's a lifesaver for weather monitoring, allowing meteorologists to track several storms and hurricanes so they can issue early warnings that protect communities.
And this is how radar system works. Step 1 is transmission. The radar system has a transmitter that generates short pulses of high frequency radio wave or microwave. And antenna then focuses this wave into a beam and shoot them out into a space. And the second step is propagation. These radio waves travel through the air at the speed of light. They keep going until they hit an obstacle like an airplane. And the step 3 is reflection. When the wave hits the target, some of the energy is absorbed, but a portion of it bounce right back toward the radar system. This bounce back signal is called an echo. And the last step is reception and processing. The same antenna or a second one nearby catch the weak returning echo. A receiver amplifies this signal and sends it to a computer processor to figure it out the target's location and speed. And all of this step, there is a physics behind the calculation. Because of radio waves travel at a constant speed, the radar simply measure how long it took for the wave to leave and return. We divide by 2 because the wave has to travel to the target and back. So how to find speed? If the target is moving, the frequency of the returning wave change. When an object is moving toward to the radar, the waves get squished together with higher frequency. If it's moving away, the waves stretch out with lower frequency. This is exactly why a police car siren changes pitch as the driver passes to us.
Next, I will explain the major components of a radar system and how they work together. Radar stands for radio detection and ranging. It uses radio waves to detect objects and determine their distance, directions, and speed. Radar technology is widely used in aviation, military surveillance, weather monitoring, and maritime navigation. Then, I will explain about the major components of radar. A radar system consists of 5 main components. Number 1, the transmitter. Number 2, antenna. Number 3, receiver. Number 4, processor. And number 5, display screen. Next, I will explain about the functions of the components. First, the transmitter generates high-frequency radio waves and sends them to the antenna. The antenna then transmits these waves toward a target and receives the reflected echoes. Next, the receiver captures the weak echoes returning from the target and amplifies them. The processor acts as the brain of the radar system by analyzing the received signals and calculating information such as distance, direction, and speed. Finally, the display screen presents the processed information, allowing operators to monitor detected objects effectively. For my final explanation, I will explain about the how radar works and the conclusions. The radar process begins when the transmitter sends radio waves through the antenna. When these waves hit a target, they are reflected back as echoes. The receiver collects the echoes, the processor analyzes the information, and the display screen shows the final result. In a conclusion, the transmitter, antenna, receiver, processor, and display screen each play an important role in radar operation. Together, they enable the radar system to detect and track objects accurately and efficiently.
Now I will be presenting real-world applications for radar systems. So radar uses radio waves to detect and track objects, making it an important technology for several things. First, radar is often used in aviation. Air traffic controllers use radar to track aircraft positions, speeds, and altitudes to prevent collision and making sure every flight is safe. Radar is also used in aircraft to help pilots navigate and avoid obstacles. Next, radar is also important in weather forecasting. It helps meteorologists detect rainfall and measure its intensity. Radar can also be used to monitor possible weather events such as hurricanes, typhoons, and thunderstorms, allowing early warnings to be issued. Radar can also be used in traffic control. Police officers use radar guns to detect vehicle speeds and enforce speed limits. Traffic lights also uses radar to monitor vehicle density and adjust the timing to improve the traffic flow. Finally, radar is essential in defense. It is used to detect and track aircraft, ships, missiles, and drones. The radar systems is also used to help with surveillance of airspace, coastlines, and national borders to enhance security.
Alright, Assalamualaikum warahmatullahi wabarakatuh. My name is DANISH QASHRI and I will be explaining our group's presentation final part. Alright, so this slide shows us about radar systems advantages and their limitations. First, for their advantages, they can operate day and night and are effective even in poor weather conditions such as fog, rain, cloud, and even a storm. Radar can also detect objects over long distance, like really long, and provide accurate measurement of distance and speed. However, radar systems are very expensive to install and maintain. They also experience interference from other signals, and small objects can sometimes be quite difficult to detect. Oh, and even though their range is very long, it is still limited. And now finally for our group's conclusion. So what can we conclude from our presentation? First, radar system uses radio waves to detect and locate objects. Second, they are widely used in aviation, maritime navigation, weather forecasting, defense, and even traffic control. And lastly, we know that due to their reliability and versatility, radar system remain one of the most important application of radio wave technology in modern society. Alright, that's all from me. I hope we presented this well. Thank you so much for listening.